Hello everyone, welcome to my YouTube channel, and in this video I will show you how to implement an air conditioning system on an STM32 board, actually by using STM32 CubeIDE program. So let's start with pinout and configuration parts. Let me show you firstly the RCC part. I just set the high-speed clock to crystalline ceramic, and I chose serial wire in the SYS mode. I chose that because I'm using we are using servo motor in this project. So if you want to use servo motor, you need to set this do these settings actually. And subsequently we are using also an analog input, that means ADC1, and it has been initialized in the PC0 pin. Then let's come to the timers. We are using two timers because we are using servo motor and also buzzer, and we are working on them by using PWM signals. That's why we needed to use two different timers. And I set the channel 4 in the timer 1 for the buzzer, and I chose channel 1 in the timer 2 for the servo motor. Let's have a look at the settings. Uh, I just set the preschedule as 355 and counter period to 1799. These are the frequencies that are supposed to be, because the board couldn't supply a 5 voltage to the buzzer and uh, servo motor, and these items are working with, if they require 5 voltage to work. So with the frequency, with the settings, we just make the 3.3 voltage to be converted to 5 voltage. That's why we are doing these settings. So these are so important for the PWM signal. These are the clock configuration. You can have a look at it. Yeah, the configuration part is over. Let's come to the code. We are using ADC, Team 1, Team 2, and UART 1. Yeah, this class is for arranging the angle of the servo motor, actually. And the servo motor turns 36 degrees in each iteration. And this is for taken input. This is for implementing the data of angle to the timer 2 library. So yeah, this is for the PWM start. We need to do it if you want to use the PWM signals. PWM, like we are using servo motor with PWM signals, so we need to make it start. And you can see we are taking analog reads by using the potentiometer. And if the potentiometer, actually the potentiometer, the max value of the potentiometer is 4,000. That's why we arrange it 4,000 as a maximum and 400 as a minimum. And in this part, we just arrange some. We just divided it into 5 different parts. In the first part, the temperature. Actually, we are using ADC input instead of temperature sensor, because we we haven't got any temperature sensor, and the logic of the temperature sensor is based on ADC input, actually, I mean analog input. So we are we are using analog input as well in the potentiometer. So the logic is kind of the same. So that's why we chose to use a potentiometer for that. And if the value is between these points, it means that the temperature is optimal. And if it's in this value, between this value, the temperature is increasing but still okay. And in this value, the temperature is on the limit. On the limit. If it exceeds the limit, the system will start and the servo will start turning as a climate to make the air cooler, and the buzzer will sound. You can consider it as an alarm. And yeah, when we come to this part, it means that the temperature is over the limit, so the system starts to work. Firstly, the buzzer starts sounding, making some noises like alarm, and it alarms. It makes a sound for each iteration. Actually, after that, three pins are uh, toggling. Actually, three pins are toggling continuously, and after that the servo class starts working. And the last one is if it's above the limit temperature, the system gives some uh, signal by using UART. Yeah, the code is like that. I mean, I hope I explained it well, and I will show you how it works on the board.
Yes, it's time to see how it works in real time, how the output is, and this is the potentiometer. But we will consider it as thermometer. When we increase it, it means that the temperature is rising. Okay, and then when we increase it a little bit, the system will work one LED. The one LED is working. That means it's okay. When we increase it a little bit more, the second one has worked, and this is the limit. When we increase a little bit, the system will start working. When we increase it, the servo motor has worked. This is the climate, actually, the air conditioning. So it's working to make the air cooler, and the alarm is also working. The buzzer is alarm. It makes soundings. It makes some noises. I think you can hear. And this is also starts working. It means that there is a danger. The temperature is above the limit. When we increase a little bit, the servo will work fastly, and a little bit more faster, and a little bit more faster. It means the temperature is very high, and it needs to work work hard to make it cooler. But the temperature is decreasing, and it gets normal, and is now below the limit. And also we can see that we are using UART. When we increase the temperature, if the system works, the system gives some signal, a random signal, to inform the user that there is a problem. The temperature is above the above the limit, so the system is working. When we increase the temperature, the frequency of the signals will be higher. Yeah, that's all